discuss about acid catalyzed hydrolysis of sucrose by polarimeter. Now we will discuss about what is polarimeter, how we use polarimeter and the parts of polarimeter. What is polarimeter? Polarimeter is a scientific instrument used to measure optical rotation, the angle of rotation caused by passing linearly polarized light through optically active substances. Now we will revise our previous knowledge about polarized light, optically active compound, optical rotation and the angle of rotation. So what is polarized light? Polarized light is the light waves which can occur in a single plane. In the image you can see that at the right terminal there is polarized light. Polarized light can vibrate only in single plane. Now, what is optically activity? Optically activity is a property of compound being able to rotate the plane of polarization of plane polarized light is called optically activity. The compound with this activity is called optically active compound. On the upper side you can see that plane polarized light is rotated and on the lower side it is not rotated. This light is rotated due to the polarizer's effect, so that the first compound is optically active and the second one is optically inactive. Now we will discuss about parts of polarimeter. Sodium light, collector lens, color filter which allow only sodium light to pass out, polarizers, half wave plate which can show four regions: full bright, full dark, central bright and the central dark region. Metallic jacket. Sample tube is fit in this region. There is a sample tube. Fill the sample tube with your solutions and close it properly after filling it. Now place the sample tube in this chamber and close it properly. After this, there is a rotatory head with which we can focus our image clearly. Vernier scale, main scale or vernier scale. How to use polarimeter? Take water in the sample holder. Water is optically inactive. We use water to check the working of our polarimeter. Take the water in the sample holder and put it in this chamber. Cover it with metallic jacket. Rotate the rotatory head until this image will appear. Now let's prepare the solution. Add 5 grams of sucrose in the beaker and adjust their volume up to 50 ml. Then mix the solution properly with stirrer. Now we will make HCl solution. First we take 50 ml of water in the beaker and add 3.6 ml of HCl in the 50 ml of water. HCl solution of 0.9 molarity. Mix with stirrer. Let's start the experiment. First we take sugar solution in the sample holder and place it in metallic chamber. This image will appear. Now we will mix our both solution, sugar solution and the HCl solution, and mix it properly with the stirrer. Take the sample solution in the sample holder and place it in the metallic jacket. This image will appear. After 0 minutes this reading will appear. After 8 minutes, after 16 minutes this reading will appear. After 24 minutes this reading will appear. And after infinity time this reading will appear. Now we will do our calculations.
In hydrolysis of sucrose, sucrose yields into glucose and fructose. While using polariometer, we use two terms, dextrorotatory and levorotatory. If light is rotated in plane of polarized light to clockwise direction, it is called dextrorotatory, and if light is rotated in plane of polarized light to counterclockwise direction, it is called levorotatory. Dextrorotatory can be denoted by positive symbol while levorotatory denoted by negative symbol. Its example is D-glucose and its L-glucose. Now we will do calculation. Here R naught is reading at 0 time, reading at infinity time, and RT is total reading, and its formula is this one: main scale reading plus vernier scale reading multiplied by least count, which is 0.1. Now we will draw a table at different times. Here at 0 time, main scale reading is 30 and vernier scale reading is 5. Now we can calculate its total reading according to this formula, which is 30.5. Now we can calculate all other readings in the same manner. Here infinity has negative reading. It shows that reaction contain levorotatory compound and fructose greater amount present in it. Since this reaction is first order, so we put all the values in this formula. But firstly, we will calculate R naught minus R infinity. Here R naught is 30.5 and R infinity is minus 11.8. After calculation, we get 42.3. Now we again draw a table at different times. At 8 time, RT minus R infinity is 37.6. Here RT is 25.8 minus R infinity is minus 11.8. After calculation, we get 37.6. Now we put all these values in this formula. Here 1 over T, instead of T we will put 8. Log R naught minus R infinity is 42.3 and RT minus R infinity is 37.6. After calculation, we get this value. And in the same way, we can calculate all other values.